Welcome to the Cosmic Pie Podcast, Season 3, Episode 29. I'm your host, Wayne Barkhouse.
And I'm Robert Moore.
We are broadcasting live from the campus of the University of North Dakota, here in Grand Forks, North Dakota.
Right?
We do have a live chat feature that's running, so if you have any comments or questions you'd like to ask us throughout the podcast, feel free to use that option.
It's an option?
It is an option today.
Okay.
You know why?
Should be a requirement. Oh, sorry.
Now, Robert, our disclaimer before we get into things.
The opinions expressed herein are those of myself and Wayne. They are not the opinions. They're of the university, the Department of Physics and Astrophysics, or the College of Arts and Sciences.
You still asleep like last week?
I am still sleep depraved. Wait.
And for those of you who like to watch your pods on Spotify, we do upload to Spotify the very next day, so there's an option there. Now, we were not here last week. We thought we could do it, but Robert is our roaming reporter.
Yeah.
He was on the other side of the country on the East Coast.
Yep.
You want to tell people what you were doing and where you were and all those fun things?
I was at a nice event called Dragon Con, which is a convention for science fiction, fantasy, and pop culture. So you will see everything going on from just partying to all sorts of fantasy-related, science fiction-related, science-related, astronomy-related topics all come up. Combined WWE wrestling is there. You name it, there's probably something for somebody. And basically, it's getting together with 75,000 of your nearest, dearest, geekiest friends, cramming them all into 5 hotels in the middle of downtown Atlanta. And it's great.
So what's the difference between like Comic-Con that maybe more people have heard about than Dragon Con?
Yeah. I can speak on that from some experience. I've met people and talked with people who've been to San Diego Comic-Con. And I've never been myself. That said, the big difference is that Dragon Con is what's called a fan-based convention. So there's a lot more programming. It's a lot less industry, movie, book, industry-driven. And so you don't get as many of the celebrities showing up, but you get enough. And you get a lot more of the, here we've got some mid-list authors come talk to you about writing. And things like that going on.
So the dragon is just obviously a character representing fantasy writing and these kind of things.
Yeah, that's it. And I say that a lot less celebrities, but at the same time, back in the '80s, Dragon Con was pulling people like Harlan Ellison, which if you're a science fiction fan, you know that name. Harlan Ellison, Ray Bradbury. All these guys were coming to Dragon Con. They weren't necessarily going to San Diego Comic-Con.
Right.
But of this type of thing, if you go to one of the majors, it's probably San Diego Comic-Con or it's Dragon Con.
And I thought I seen something that you might have put on Facebook or something while you were away. Was it like 75,000 tickets sold?
Yes, they capped the all weekend passes, the 4-day weekend pass, at 70,000 now.
70,000?
But then they'd sell 1-day passes, and there is no cap on those.
Right.
So if you just want to show up for 1 day, Saturday or Sunday or even Friday to a degree, you may be talking about 100,000 people in those hotels.
Wow.
Yeah. So it's a big event. I mean, think of taking Grand Forks and dropping it in a 5-block radius. Yeah, that's what's going on. And speaking of which, if you don't mind, we'll go ahead.
Well,
let's go ahead. Wait.
Yeah,
okay.
I just had one other question. So I know there's like smaller cons.
Yes.
So that's what, did you just offshoot mainly of Comic-Con then? Or do they have smaller Dragon cons in other places?
They just have, these things have been popping up, as Extra Bullet pointed out. He's old enough to remember, and I am too, Coast Con, which took place in Biloxi, Mississippi when we were kids.
Okay.
So these things have been going on pretty much since the 70s. Now, Dragon Con got started in 86. And back then, there was less than 1,000 people that showed up. And in fact, it wasn't until about 2012 that you got more than 5,000.
Any relationship to Dungeons and Dragons?
Oh, there's plenty of that going on there too.
Is that part of where the name comes from then?
That is part of where the name comes from.
Because, I mean, there was a big following of that. I think that started in the 80s at some
Yep.
point. And then eventually, wasn't there a movie made about it?
There
Dungeons
have
and
been
Dragons,
several.
like a Hollywood movie or
Yep.
something?
And the most recent one is, in fact, back in 2022, I think it was.
Okay.
So
I also know Star Trek, right? Because when Star Trek original series in the 1960s, that wasn't that popular.
right.
And so it really became popular later on. It wasn't through the following of people going to Comic-Con and stuff, kind of.
It was. And there were
Yeah.
various Star Trek conventions. So all of these things started out small. And it's a matter of, you've got Dragon Con and San Diego Comic-Con and a couple of others that just blossomed into something much more popular culture driven. And in the case of Dragon Con, party driven.
Well,
We can discuss that in a little bit, but
yeah.
But you still got plenty of smaller ones. There's one down in Fargo, south of us, that is called ValleyCon, and it's for a regional con. I mean, it picks up 1,000, 1,200 people, I think.
Right.
And back in Cleveland, where my family still resides, there's Concoction and Con on the Cob and quite a few others.
Con on the Cob.
Con on the
You
Cob.
figured that would be in like a Nebraska or something.
Right? You would. But no, it's there in Ohio.
Yeah. Or you're at the Corn Palace in South Dakota.
There's one called Odd Mall, and it's just,
Can we
luck
have
of
a
the draw.
Robert, can we like have a Cosmic Pie Con or something?
If we get big enough, I'm sure we can.
Okay, you're going to start by showing us
All right.
some of your adventure.
I mentioned some of the crowding, so I've got a little clip here. First off, of what it looked like Friday walking through one of the main hotels, Marriott Marquis in downtown Atlanta. So this is what it looked like. Some of y'all may recognize this hotel. But as you can see, all kinds of costumes and everything. And it was rock. Got the sound of it's just noisy.
Oh, you never know what to say, so you have to be careful.
This is the crowd on Friday night. It got worse than Saturday.
Well, I noticed it's a huge range of people too. It's not like all young people or whole mixture of it.
So, I just
What was that, homeless or something else?
homeless and bad.
So this was on Labor Day weekend.
This was Labor Day.
And the sample right there, here's where he goes and starts delivering gifts. Wow.
Dragon Con is every Labor Day weekend.
It was like a built-in antenna in your head that one goes.
Dark Dog.
Now, if you're like some of those people that are not wearing a costume, do you look like weird?
Nope.
You know, you're comfortable.
So that was that clip. So, that's what's going on. So what was I doing there? I actually volunteer for the con. There's various programming tracks. There are where you get together in certain types of panels, we call them, where we get people who are experts in the field show up and, they couldn't hear us. Well, darn.
I guess they couldn't hear us while the thing was playing. Do we have our mics on there for that video?
The video was coming through.
Oh,
Oh,
and we weren't.
and we weren't. Well, well,
Okay.
that was unexpected because we can't hear the sound from the video.
Hopefully nobody said anything in.
I don't think they did. I think I screened them well enough for that. But the programming track that I volunteer for is, naturally enough, Space Track. We're part of a group of programming tracks that we say bring science to your science fiction. They include science, space, EFF, Electronic Frontiers, as it's called. We just call it EFF, Skeptics, and some others like that. And so one of our pieces of programming we do in space is starting at 11:30 at night. we have a professor emeritus
Right.
from the University of Alabama and another professor from Wesleyan University in Middleton, Connecticut. They do what we call night astronomy, and this is where they remote in to telescopes like at La Palmas or Sierra Tololo or Kitt Peak. So major observatories.
So Canary Islands, La Palma.
Mm-hmm.
So remote observing, right?
Remote
so they
observing.
log in remotely to a computer. And so there's somebody on the other end then knowing that they're logging in from Dragon
Yes.
Con and have it all set up ahead of
Have
time.
that all set up ahead of time with
Yeah.
Bill. Bill is the professor emeritus from University of Alabama.
Right.
And so people go off and go, yeah, how many people actually show up for that? Well, this is how many people show up for that.
So is everybody here for night astronomy?
Hopefully you can hear us, but yeah, it's probably still pretty loud in the video. So, yeah.
Excellent.
So the video is pretty loud on y'all's end.
Yeah.
Wayne just turned it up on his laptop. But what I was saying is that was a normal crowd for showing up at 11:30 at night to watch him monitor and use these telescopes to shoot images.
So how late did he go till then?
We went
Evening.
that particular night. We went to 3 a.m.
Oh, wow.
And this is all Eastern time.
Right.
So, yeah, people stayed up for 4 hours.
So these are serious panels is the
Mm-hmm.
important thing to say. They're not just make-believe things or whatever. There's actually some really important things that are being discussed.
Yes. And we discussed topics such as things we've discussed here, Europa Clipper, Dragonfly, these new space missions, old space missions, Voyager and what it's doing, and all of this. And we even had one panel this year on a gentleman who's working with a research group that may be able to get us a warp drive. And then I hesitate to say too much about it, but then again, it was a public talk. Instead of trying to do like the Abergean drive, or
Yeah,
whatever,
the Mexican.
where he warps
Yeah.
kilometers of space ahead and behind the thing,
Yeah.
they're looking at it from a problem of microns, but doing it millions of times a second.
Wow.
And
Interesting from the point of view of quantum mechanical aspect of space.
that's what they're getting into.
Yeah, that would
And-
be the interesting part.
So what else goes on? Well, we come to DragonCon for the costumes. So there's things like this. They were all, Rosie the Riveter was all over the place. If you're old like we are, you remember the Jetsons cartoon and Rosie the Robot. So a bunch of people, for some reason, decided to make Rosie the Riveter. Then there's these guys. DragonCon loves its cults. What we call cults anyway. And one year, this guy in the middle on the big circular panel.
So these are Trump voters that we?
No,
just
no,
kidding. I'm
no,
only
no,
kidding.
no,
Just
no.
kidding. Just kidding.
But it was a cardboard stand-up of a FedEx delivery driver, and people just started decorating googly eyes and things like this. And so the Cult of John, the FedEx driver, developed. And this also includes the con of the Marriott carpet, which is that pattern on the hat of this nearby guy. And bottom line is it's a cult of FedEx. So they make statements like, he will deliver for you,
Well, it's a good thing he didn't do a cult of DHL
right?
because they no longer deliver to the United States, is my understanding.
But of course you've always got contrarians. They don't want to be in the cult of John. So you've got the UPS heretics. But then you've got all these little creative people. This lady created this arm puppet dragon out of high density foam and fabric. And you run into all kinds. This lady was a line buddy, by the way. I was waiting in line to get into a particular piece of programming I wanted to. And we just started talking. And she
Right.
was okay with let me take her picture with her nice little creation here. And,
And what is that creature?
It's a dragon.
Okay, it is a dragon.
Yeah, so she's got her holding up its wings, and she's got its head that'll mouth, open and close its mouth. She even had smoke that would come out of its mouth.
Wow.
So, the costuming skills, even if they don't, wow you necessarily, are impressive, which is why there was this shrine at DragonCon Because Joanne Fabrics and Crafts went out of business. And that's where a lot of the cosplayers got their fabrics and yarns and things.
So you gotta go to Hobby Lobby now or something?
Yeah, they pretty much have no choice. But, Joanne and Fabrics and Crafts stores is no more.
Oh.
Vendors get in on the Dragon Con thing too. So one of the vendors is it's an advertiser. This is for Netherworld Haunted House, which is one of those premier haunted houses that you pay $20 and get the ever-loving life scared out of you.
So where's that at?
It's in Atlanta.
Oh, there is one in Atlanta. Okay, well that's convenient then.
So
It's local.
it's local. And we have at least one, I understand, around here that does kind of the same thing. Probably not to this level, but Netherworld makes, hundreds of thousands of dollars, so they can go all out.
Do these run all year round or just around Halloween time?
Just around Halloween, usually from about I know for a fact they open in October and run through just before Thanksgiving.
You could imagine them at state fairs and stuff, right?
Mm-hmm. Yeah. So they advertise by coming to things like the Dragon Con. Then you've got.
Oh, before I forget, was there anyone there like from federal agencies like NASA or anything?
Yes.
Okay.
We had people like Trina Ray, who will be one of the main mission scientists on Dragonfly. No, not Dragonfly. She's on Europa Clipper.
Okay.
Kim Stedman's on Dragonfly, and Trina Ray, who I just mentioned on the Europa Clipper, she was a main scientist for Cassini. I'm trying to get her to come on.
What about booths like NASA exhibitors, the booths?
It has. Let me switch back to us.
Yeah, there's a reason
has
why I'm
happened
asking.
before.
Right.
They weren't there this year, but there have been NASA booths before.
Okay, and the reason I ask is because of the budget problems that's occurring right now, the federal budget, that the American Astronomical Society meeting that was in Anchorage just a few months ago, talking to somebody who went there, and that's usually like exhibitors from all over the industry, government agencies, you name it, NASA's there, obviously. They weren't there this year.
Right.
Because of these
because of
budget
the
uncertainties, right, and
in
what's
fact,
going on.
3 of our panels, and it was kind of a downer, but it was there. 3 of our panels were about the budget cuts to NASA, to universities, to things like that.
NSF, so on.
And yeah, it hurts. But it needs to be talked about, especially among people who support these types of programs. Because if you do support space exploration and science and research in general, it's time to get busy, folks. It's time to start saying, hey.
Well, the thing is, if we don't do it, that is the United States, other countries are going to do it. We're going to get left behind. And you might say, oh, way out ahead, how we ever get left behind? Well, people can catch up eventually.
Right. In fact, we're not that far ahead anymore.
And if you think of the development of things like quantum computing and the AI technology that we hear all the time, and everything, that's the buzzword nowadays, AI this, AI that.
Yeah.
I'm waiting for them to, like, at Menards to have an AI toilet or something,
That'd probably come from Japan.
Or China. But,
Yeah, well.
but anyways, it doesn't take long to get left behind, and it takes a lot to catch up.
back
You
up.
can't just say, here's $100 million catch up. Well, I don't know about that, but it's going to take a while.
Yep.
So that's the problem. And not only that, I'm hearing horror stories, and this is scary, that some of the younger people who would look for a job in the STEM-related field, want to get an education and then get a job right away, of course, are starting to look at other countries, even Americans, or
Even
looking
Americans.
at Europe, for example, to possibly going there for their higher education and then
Yes.
hopefully get right into a job there rather than here.
Rather than coming back here.
That's what we call a brain drain.
Yep. So
So we'll see what happens.
let's see what happens. But anyway, all this fun, all this happening and everything, by Sunday, you look like this. I was posting this on my Facebook going, help, I've Dragon Conned and I can't get up.
This is after he drank 3 cups of coffee, folks.
Yeah, pretty close. So that's Dragon Con. That's what I was doing all Labor Day weekend.
You were probably like that and worse than on Tuesday when we were going to do the podcast.
Right. I'm afraid so. Yeah, I'd been up all
What
night.
is your name?
I'd been up all night in Hartsfield Jackson Airport in Atlanta because the earliest flight I could get back was Tuesday morning. at
Right.
6.
Well, how was your back laying on the floor at all night?
No, it wasn't that great. And so forth. So
Sleeping in airports is only for people who are like less than 30 years of age old, Robert. No one ever told you that?
No. Well, and they really make it difficult because they put all these arms
Armrests, I
on
know.
the seats.
Because they don't want you to sleep.
Right.
Because that's pretty obvious. If they did, they'd have something. They can afford to have a nice little thing that lays out horizontally with a little bit of foam to it, and you can lay on there
Right.
with a built-in alarm clock so you don't miss your flight. But no, they want you to sit up like a robot all night long and feel like crap, basically. Right?
Basically.
I'd even pay extra, to have that comfort at the airport.
Well,
so.
funny you should know, at the airport, one of the concourses, there was a little kiosk where you could go down the hallway, and they had little suites
Oh, nice.
where you could actually crash out on a couch for a little while in the airport. But, I looked into it, and it's,
How much was that?
you would be better off going and staying at the Hilton an extra night.
$50 an
at
hour.
$250 a night and getting an Uber to the airport
Right.
than you would trying to get a full night in one of those. So,
Yeah. You look at that and go, sweet.
so last thing on DragonCon I want
Yeah.
to mention is every year my track director that I volunteer for creates these challenge coins. And I got permission.
Oh.
Wayne, here you go. Welcome to the space track.
Oh, is this mine?
That's yours.
Oh, good, because I was
So
going to
this
put it in my
is-
pocket and walk away with
Yeah,
it.
this is the 2025 space
See if we
coin
can get that on
challenge
camera.
coins. See if we can do it. So it's about the Vera Rubin telescope.
Very nice. Thank you,
And
Robert.
the other side is, of course, our track logo, which is, of course, the constellation Draco. And that's our challenge coins. Every year we take one space-related topic, or our track director does, puts it on one side of the coin, and puts the logo on the other.
So what do you do with these coins then? Do you
I collect them, but
Okay.
I may start carrying one around because I know certain people in some of the groups
really
that I
good.
hang around with do challenge coins where they'll drop a challenge coin, and if you don't have one to drop, you buy the next round type thing.
Okay. So is everyone who volunteers gets one of these?
Everyone who volunteers gets one. All of our guests, our panelists,
Oh,
get
yes.
one.
Okay. Yeah.
So then she sells them for $20 each to go to the charity for the con picks every year a charity. And she sells them for $20 to our fans
Right.
to donate to the charity, which this year was NAMI, National Alliance for Mental Health or something like that.
So do they ever have trouble of people volunteering to help with the organization of the Dragon Con?
They don't generally have trouble with that other than people volunteer and then don't show up.
Oh, I see.
And so
So the day of different events, there's not always the right number of people helping out, I guess.
there are certain groups, apparent volunteers at the con that are chronically underhanded, tech ops, because you have to have some experience with tech op, with
The equipment.
sound and lighting and
Right.
equipment, or they can't take you
Right.
because they need people who know what they're
What they're doing, yeah.
So tech ops is always chronically shorthanded. We used to be called security. I volunteered for them for 2 years, but I think now because they are volunteers, they're now called safety.
Okay.
It's usually chronically underhanded, but that group is responsible for the line starts here, type stuff.
So the tech stuff, I think you could volunteer for that. We have enough tech issues that we had to deal with over the years with your podcast. So.
Yeah, but I'll stick with space.
So if you volunteer, I guess you get your registration paid.
Well, the first year you still have to pay $20,
Okay.
but after that, yes, you get your badge for free. You were kind of expected to put in 25 hours of effort toward the con, which still leaves plenty of time to go find the things you want to see and do. But for some people, it's too much.
Do you get any free meals out of it or anything?
You can. There's a volunteer village where you can go relax and have a soda and some
Okay.
quick cold cut type foods, and
So if you don't have a lot of money and you want to go, that's one way to
it's
do
one way
that,
to do
right?
it. The only thing I had to pay for that weekend was essentially the meals that I didn't take in the volunteer village,
Right.
and my hotel room, which was split between. There were 3 of us in the room. A lot of people put 5, 10 people in the room.
Right. How do you get to sleep with 10 people in the room? You
Well,
take turns, I guess.
No. Well, there is some of that, but it's also a matter that there's a lot of floor sleeping going on.
Oh, I see. Just to reduce the cost as much as
Just to
possible.
reduce the cost. I mean, yeah, even with the con rate, as they call it, the Hilton is $250 a night.
You know, I can remember going to elaborate professional meetings, and the cost was over $200, and I thought, oh my God, like as a graduate student, right? That's so much money. I could go somewhere else, like for $50 a night.
Yeah.
But $250 now seems to be almost the norm in a lot of places. Especially in the larger cities.
Well, it doesn't help that when I first started going in 2001, there were the Motel 6s and the Super 8s that were nearby,
Right.
that were within walking distance, that still charged Motel 6 and Super 8 prices. And then they started realizing that Dragon Con was happening. And all of a sudden, your Motel 6 costs $200 a night.
Yeah.
And so now to get normal room rates, you've got to go out to Uber driving or further distances.
Yeah.
So that is one aspect that's not so great about the con. But again, get together with 5, 6 of your best friends,
Right.
split the room cost, bring some air mattresses, and it's still
There you
not
go.
that unreasonable.
Well, at least it seems like you had a good time.
Oh, yeah. Yeah, still recovering. Still getting back in the groove of real world. But
Right.
so,
Okay.
yeah. All right. So what's been happening in the world of
Yeah. So,
space?
well,
So-
lots in the last 2 weeks.
So we've had something with Starship.
Yeah. So Starship finally was launched, and it was just the same day as our podcast. Actually, when
okay.
we wrapped up at the podcast, by the time we get back to my office, it was ready to go at that point. So it's
Okay.
been, 2 weeks since it flew. But it's really arguably one of the more perfect launches, if you like,
Okay.
in recent times. So we had one engine that flamed out. And so it wasn't perfect in the sense of all the engines ran perfectly the time that they were allocated or supposed to run. But a lot of the engineering stuff was done like as it should. In fact, this is a nice image taken from a drone, I guess, a boat drone
Okay.
that
I was-
was in the Indian Ocean, waiting for it to. You don't want to be there just in case it misses its
Yeah.
exact target or blows up on
I
impact
was,
or
I
something.
was about to say this one didn't RUD or
Yeah, that's right. You didn't have a lot of those other problems. And then
Okay.
I noticed on watching it, I didn't watch it live, but watching it later that same day, there was some burn through in some parts of the vehicle,
Okay.
but not as much as what we've seen in the past.
right.
So whatever changes they're doing a lot. And this is a prototype. This is not the actual design that's going to go anyways for real.
Okay.
Right? They're soon going to go to the next version and so on. But they're certainly, the engineers are nailing down a lot of the problems that they have been having lately. And there's a lot, you might say, okay, it's a private, industry, a private company doing these things. Why should I really care? It's not my money.
Right.
It's not like it's a
Except
public.
it is your money.
Well, the thing is, both SpaceX and Blue Origin have won the contract from NASA to build the lander to
Right.
go from lunar orbit to the surface and back again. And if those landers don't get built or not built correctly, that's going to hold up the Artemis project. So that will matter to the taxpayer of the United States and other countries that are involved in Artemis,
Right.
the Artemis Accords signatures. So the thing is, we need SpaceX and Blue Origin to develop their vehicles, and right now nothing is ready. So even if we went today, Robert, to the moon and we have a vehicle ready to go, there's no way to get from lunar orbit down to the surface. And as we know, other countries, and one country in particular, is working on just
working
that.
on
And
just
we
that.
have talked about that in the past as well. So we wish SpaceX, a lot of good, hopefully, progress in the next few years at least, so it can satisfy that contract.
Them and or Blue Origin.
And Blue Origin as well. It's nice to have both because you never
it's-
know, and it's
right.
good for backup.
It'd be nice to have Boeing in there, but Boeing made some questionable choices, and they're paying the price.
Right. Now, Starship 11, They let the engines. They test fired the engines this past weekend.
Okay.
So it is expected that it will launch somewhere near the end of September. So they're
Nice.
going to come faster now, which is nice to
Cool.
see. But so
Yeah.
we'll see how that all works through. Anyways.
Cool.
Yeah.
So what's this about?
Yeah, so the other thing is that the European Space Agency has launched a vehicle several years ago, back in April of 2023, so over 2 years ago, to go eventually to the Jupiter system of moons. It's almost like you were talking already about the Europa Clipper.
Mm-hmm.
It's similar to that. So in some sense, it's complementary to what NASA's doing with its spacecraft. So it's going to arrive in the Jovian system in July of 2031. And its main mission, of course, is to study the Jupiter system, Jupiter and its moons. But to fly your spacecraft directly to Jupiter takes a lot of energy,
Right.
which means you need a large rocket, which means you need a lot more money than if you sent your spacecraft on a much smaller rocket that's cheaper, but then you got to take the roundabout way, the milk run, if you like, of space exploration. And you can see from the diagram here all of the different flybys of both Venus and the Earth that this mission called the JUICE mission will undergo. And JUICE, by the way, as you see in the bottom, stands for Jupiter Icy Moons Explorer.
Mm-hmm.
Okay, they don't say what
I
type
don't-
of juice, so not
yeah,
orange
and-
juice or grape juice. But anyways, it flew by Earth moon system after it was launched in April of 23 and August of 24. Then it flew by Venus just a few days ago, so a couple weeks ago.
Okay.
This was the news that everything was going on. There was a problem with the vehicle,
Oh.
and they managed to get it fixed just prior to the flyby of Venus.
Okay.
There were some
That's
communication issues, so thankfully that all worked. So it flew by Venus in August of 2025, but the way it flew by, they weren't able to get any images. There was no images planned at that time, so we don't have these nice close-up views of Venus when we flew by
Right.
that. And then notice that the route that it takes, it will fly by Earth again in September of 26. So three years after its launch, more than 3 years. So 3.5 years after its launch, it flies by Earth. It's like you're not getting anywhere. You keep coming back to Earth. What's going on? That's this milk run business, right?
good. Yeah.
And then
it's got to pick up enough energy to get out there.
Yeah,
get
it's using the
speed.
gravitational slingshot effect. It's using Earth's gravity in this case and the gravity of Venus to add energy, kinetic energy to its motion, so
Right.
it can have enough energy to get to the outer planet, out to Jupiter. And it finally will fly by Earth in January of 2029, so nearly 6 years after launch. And then from there on, it's heading towards Jupiter, and with arrival, as I mentioned already, in July of 2031. So hopefully the spacecraft is still working. So there's a couple problems there, and it's been like this for decades now when we use this kind of technique to get to various planets. Number one, the longer a spacecraft is in interplanetary space, the more chance something can go wrong.
Right.
And the other thing is, of course, is for people who build these instruments and careers are, wrapped up into all of this stuff, they have to wait all of that time before they get science data and can start publishing things.
I mean,
you
it's
see.
8 years.
That's a
getting
huge
close to half of a career. Right
Yeah, that's a
there.
huge investment of time. So you better be doing other things besides just being on the JUICE mission. You can't just
Right.
rely on this. And of course, something can go wrong and you never get anything.
Right.
Because just when you arrive in Jupiter, the radio goes kablunk in all the backup systems and there's no way to communicate with
Or
it
an
anymore.
instrument doesn't open up, or
Yeah, anything can happen, right? So you have to, and Jupiter's a harsh environment. Some people don't realize that it's a lot of radiation, and so you got to have special hardened components in your spacecraft, or fly far enough away from the planet that you're not going to get hit by a lot of this radiation that could potentially, cause a lot of damage to your instrumentation.
right.
So you have to be very careful on that.
But it's looking at Ganymede, right?
Yes,
from
that's
this?
that's right. So it's going to look at a lot of the moons. Ganymede is one of the primary targets, but it's really complementary to the Europa Clipper mission.
Okay.
So we'll have both of them in the Jupiter system. Europa Clipper will get there a year before JUICE,
Okay.
and then JUICE will arrive on station. And so we should have hopefully both spacecraft functioning at the same time.
Nice.
So there'll be some nice data that'll come back from that.
All right.
Okay.
So this is Psyche.
This is Psyche. So Psyche is a mission to go to.
Psyche,
Psyche.
which is believed to be an iron asteroid.
Yeah, very metal-rich asteroid, one of the most metal-rich asteroids that we know of in existence in our solar system. And so this spacecraft then was launched, I think it says there, in July. Oh, the image was taken in July of 2025, launched in 2023. It will arrive at Psyche in 29. So it'll orbit the asteroid for 817 days, so that's planned. It's an ion propulsion engine, and so after that, they're going to move it off to somewhere else. That's the plan. They can change this, of course, if they find something very interesting. I think the idea is if you study the asteroid for 817 days, are you going to learn any more by staying there another day or two? You see,
And
probably
the
not.
answer is probably not.
Yeah, so they'll probably exhaust whatever scientific analysis they plan to do at that point, and then move off to somewhere else.
And I'm betting this image is from the guidance camera, if it's using an ion engine.
Yeah, exactly. It's the imager that was.
Oh, okay,
right?
so it's the full imager.
Yeah.
Okay.
So the thing, image was taken at a distance of 180 million miles or 290 million kilometers for our metric friends, looking back at the Earth-Moon system. And not only there's a close-up in the inset that's there, but not only that, but you can also see stars, notice.
Mm-hmm.
So from the point of view of the spacecraft, where is the Earth-Moon located and what constellation? Right, and you can see that information there by seeing the names of the stars.
Of the stars.
Yeah, so that's really cool in that sense. But notice that even at this distance of 180 million miles, you can easily see the moon of the Earth-Moon system. And notice how bright the moon is. So the moon is relatively high albedo, given what it's made up of,
Yeah,
right?
and what's impressive is that it's still got half the albedo of Earth.
Right, yes.
So, I mean, if you're ever curious, look up pictures of andesite and and basalt, because that's the rocks that we see on the surface of the moon, and see how light or dark they are. And that gives you an idea of just how little light the moon's actually reflecting. But the Earth has clouds and all this sort of stuff. So
Yeah, it would be hard-pressed if you entered our solar system, let's say you're aliens from somewhere else, you enter our solar system that you wouldn't see the Earth, like it would stand out. And same as Venus.
Yeah.
Because Venus even more so.
Mm-hmm.
But it's just, of course, the conditions on the surface of Venus and its atmosphere is not conducive to life as we know it, as we say. So,
yeah. So what else have we got about Psyche?
well, the other thing is you get an artist's drawing of what it looks like, and it's interesting to note the size of the solar panels. I mean, these are huge.
Huge.
What's the
Compared to
reason
the-
for that, Robert? Now, what do you think?
Well, because, I don't know, light intensity drops off as 1 over the distance squared. So getting to the asteroid belts, you're out past Mars. So you're about 2.5 to 3 times the distance, or the Earth-Sun distance. So you've cut the intensity down by what? A fourth?
Yeah.
Fourth or fifth?
Yeah, fourth.
Okay.
Yeah. So that's the problem. So to explore then these asteroids, which are a lot further away than the Earth, so they typically lie between the orbit of Mars and Jupiter.
Mm-hmm.
If you want to use solar radiation, then you need these very large solar panels to have enough collecting area to provide enough power to run your instruments. And if you don't do that, then what's the alternative, do you think, Robert? What would we use?
Well, I'd use a radiothermal battery, but we're running low on isotopes for that.
Yeah, so you make your spacecraft nuclear, essentially.
Right. Yeah.
And therefore you wouldn't have to worry about solar panels. So there's got to be some source. You can't not have energy being generated somehow.
Right.
And that's a problem. I mean, we'll see that as we get into other things like on the moon. We talked about that NASA deputy, well, not deputy, but he's not the director, the head of the administrator of NASA, but he's the fill-in, whatever
Yeah.
terminology you want to use for that.
What's that word? Interim.
Yes. He had mentioned that the United States was going to put a fission reactor on the surface of the moon because they need a way of generating energy. The alternative is you could stretch out a whole bunch of solar panels on the surface of the moon and generate energy that way. But then you have to worry about dust and stuff, and your
And
efficiency will go
micrometeorite
down.
impacts.
And you get that too. So there's a lot of problems with it. So nuclear is really the way to go. It's most
really
the
is.
efficient way.
Yeah, I hate to tell people this, but it really is.
And exploring an asteroid Psyche, I mean, this is not the first asteroid, so you know what's happening. You can vision in the future. We'll be sending up probably, maybe a good idea would be these microsatellites, small miniaturized sort of buses, as they call them in the industry, outfitted with micro and nanotechnology to make things extremely small and really energy efficient. And maybe you could have the surfaces all lined up mostly with these solar panels that are really high efficiency or something.
Right.
And you send out, instead of one, you send out thousands of these things. It's like drones. You know, you see the drones nowadays that make up the fireworks display instead of using real fireworks, right? They program to do the patterns of different things you can make in the sky.
Yeah. Or, and you outfit one of these with a little mining capability, and it can land on one of these things, grind away at it, get the materials it needs, and duplicate itself.
Right.
Oh, wait,
Van
that's
Neumann
called
probe.
Van Neumann probe.
Then they come back and take over us on the Earth, right? V'ger.
V'ger.
Anyways,
We're dating ourselves, sir.
so I know in the future, chances are something like that's going to happen.
Yeah,
right?
absolutely. I mean, that would be the way for us to explore the local region of the galaxy. So.
Right, and the advancement of drones technology on the Earth, which driven unfortunately by war, for example,
Right.
is really something when you see what has happened in the last couple of years, and that's only going to continue. That sort of development.
To get worse or better.
And let's just use it for good things like exploring the solar system. Let's not use it as an instrument of war, please.
Please.
And the reason to do that is we don't war with each other. How about that novel concept, right?
Yeah, that'll happen.
That's the other thing. But anyways.
So.
The other thing that's been on the news, and it's been on off and on. In fact, it's been on the news yesterday.
Oh, okay. I don't watch the news regularly, so.
Shame.
Yes, I know. Shame.
CNN will come looking for you or something, right? So this is what's going on with this interstellar object, the Comet 3I Atlas. So there was a lot of talk, especially early on, where people suggested, well, we have to look at all possibilities. It may not be a comet, it may be an alien spacecraft. Well, there's been absolutely zero evidence that even would suggest that. In fact, a lot of telescopes are training on this comet as best they can right now because it's soon going to make that close flyby of the sun. And unfortunately, the Earth's on the other side of the solar system from the comet. And so therefore, we're not going to have that great of a view soon. So now's the time to get all, as it gets closer, there's a certain sweet spot that you can take observations. Then you got to wait for it to get away from the sun again and then do some more observations before it gets too far away from the Earth. Right. So you have to watch it. You can't just go at any time you want, obviously. So this is images that were taken from the James Webb Space Telescope. Now, we know James Webb is mainly an infrared telescope. It can observe in the optical, but its primary function is to observe at the infrared wavelengths. And it makes sense that you're going to look at the comet if you get a chance, and that's exactly what people have done. So they've looked at the comet, and they detected various things. It also can look at the spectrum of objects. It has a spectrometer on board the telescope. So what you see there on the far left is an image taken in the infrared. In sort of the middle is an image taken at carbon dioxide wavelengths. And finally, the image on the far right is water, H2O. And so both water and carbon monoxide, CO, carbon dioxide, CO2, and your favorite,
carbonyl sulfide.
That was also detected.
Cyano.
Yeah. That was also detected. Now, people are always looking for differences between this object and maybe other comets that we have seen, and I don't blame them because this comet is on an orbit such that there's no way that it originated in our solar system. It had to come from outside. And when it was first discovered, it was within our solar system. Right. It wasn't like it was near some other star and we had waited for it to get close to us. No, it was within our solar system.
Right.
And the thing was extremely faint. Only very large telescopes were able to keep track of it initially. Now, smaller amateur-sized telescopes are picking up this comet. And there was images I noticed that was on spaceweather.com yesterday, and people were taking images of it, and you see the beautiful green color. Now, having a comet look green is not unusual. Many comets are green.
Green.
But what causes the green color of comets? Do you remember, Robert?
That's the cyanogens, the carbon nitrogen molecules.
Yeah, the carbon, like the C2.
Yep.
I mean, the diatomic carbon is one of the major species that's responsible then for the green color. But there's a lot less carbon in this comet than normal. That's what they're trying to say. In fact, the JWST observations actually says that there's about 3 times more carbon dioxide than most comets. Just that there's not as much of the C2 that would be responsible for mainly the green light.
Right.
So it must originate from something else. That's what's going around now as of the last 24 hours.
And we've kind of surmised that from the eye behind it is that this is an interstellar object, but it's behaving like a comet. So call it what it is.
Yeah, so everything shows that it's a comet. You can see the tail and the coma, all of the characteristics that we know comets have. But when a comet like this originates outside the solar system, and there's no doubt about it, that's 100% certain,
Right.
then why should it have exactly the same chemical makeup as comets that originate in our solar system?
And in fact, I would be surprised if it did, because it did originate from a different star, a different molecular cloud collapse, and all of this stuff. It should have a different chemical signature.
One would expect there would be different isotopic mixtures of things and so
Right.
on, right? Different isotopes that come in different quantities or abundances, as they say, relative to some other species.
I would be absolutely astounded if it showed up being like, our comets from our own system.
Yeah, and we know things vary, right? It's not unusual. We can measure the abundances of nebula, right? Molecular clouds, all of
Right.
these things. You can measure the composition of stars all through spectroscopy and so on. So we know that abundances vary. In
Right.
fact, one thing that we like to do, and we're looking at stellar nurseries, is look at how much, for example, molecular hydrogen exists.
Right.
And molecular hydrogen is extremely difficult to detect from the ground because most of the emission lines are in the ultraviolet and some in the infrared, so you really have to be above the Earth's atmosphere to detect it for a high signal to noise.
Right.
But we use carbon monoxide, CO, as a tracer. Just like you have a tracer in the propane that you use for your barbecue to give it an odor,
Right.
because propane is odorless.
Right.
So you imagine how would you pick up a leakage, right, of propane if there was no odor in it? It'd be very difficult. So CO traces the carbon, traces the molecular hydrogen. But who's to say that the ratio
It's the same.
is the same everywhere? And it's not. You'd expect it to vary, just like you'd expect abundance ratios to vary in this
Yeah.
kind of thing now. So, but there's absolutely no evidence at all that it's some type of spacecraft.
It's not altering course. It's not doing anything.
So why would you go to something that would be extremely highly unlikely and say, "Well, I think we should look at this. That's probably might be an alien." I'm not saying it is. I'm not saying it's aliens, but it's alien. This kind of idea, right? Well,
Right.
because that makes the headlines, and you get your name out there in the press and public awareness and stuff, right? And all this kind of stuff. And it doesn't matter which institute you belong to, right? If you say stuff like that, you're not a good scientist, in my personal opinion.
I will agree.
So-
Like you said, you're trying to drum up, put your name out there, and stir up some controversy.
Yeah, that's not how science works.
Right. So what else about the comet?
Yeah, so this is a plot from the paper that describes these observations, and this paper is under peer reviewed, so it's not been fully accepted yet for
Okay.
publication, so be aware of that. This is a plot of some of these type of objects, these comets of different types, even Centaur asteroids are in here, Centaur objects.
Okay.
And what we have on the y-axis is the ratio of the carbon dioxide to water, so
Okay.
CO2 to H2O, the abundance ratio. And on the x-axis is the distance from the sun in astronomical units. So just to remind people, if you're a distance of 1 AU from the sun, that's same as the average distance of the Earth from the sun.
Okay.
Okay. And what you have there in terms, you have like a trend line, that's the dash diagonal line, some data points scattered above and below it. That's where most of the comets, the data sits. And there are a couple objects that are really strange. One is a really bizarre object. It's Comet 2016 R2. That is not an object from another solar system. That is an object within our solar system.
And that's really
Yeah.
weird ratios.
And the other one you see is the 3-eye atlas, the one that we're talking about here today. That's the star symbol. And notice that it is above that trend line quite a bit.
Quite a bit, more than 2 sigma.
Yeah, that's right. It is definitely a much higher abundance of the carbon dioxide to water as we'd expect for comets within our solar system. But notice, because we have one that's even more extreme than that, number one, maybe the measurements are really not that robust.
Right.
And so if you took a much better measurements of that object, that would have driven the abundance ratio down. Right,
For 2016,
to 2016 R2, more in line with what we see nominally. But clearly, 3-eye atlas is at a point now we have really good measurements of it because it captured people's attention, especially where it's from outside our solar system. And that clearly, as you said, highly significantly above the trend line, many, several sigma above. So why is that the case? Well, you don't have to go to extreme hypothesis. You just say, the abundance ratio varies from place to place in our galaxy. We'd expect that. Just like we expect the properties of planets to vary within our solar system and in other solar systems. We'd expect that kind of variation that would occur for comets. And so that's probably the most likely explanation of that. The cool thing, though, is when it gets hopefully a little bit closer, and there, like I said, the closest point to the sun is next month, that we'll get a little bit better data in terms of signal to noise. So we'll be able to detect with certainty some of the more weaker species.
Okay.
And I'm always looking for, is there something like neat, like something unique and novel that we'll detect in the spectrum of this comet?
Right.
That really
Something we haven't seen in anything.
in any comets, that we have in our own solar system that would give us a hint on how things are different. This is all new, right?
Absolutely.
This is the first real good comet that we've studied, even though there's been like the comet Borisov, right? That came from another solar. We didn't have good measurements of that, you see?
Right.
This one was discovered early enough that allow us to, plus we didn't have the James Webb Space Telescope available at the time.
Right.
And that really, really helps.
And that's something that is also indicative that this is an interstellar object, is it's coming in very, very, very fast. I mean, ludicrous speed comes to mind, and I'm dating myself again, but with a movie reference. But, even unbound comets from within our own system do not come in this fast with this much energy. So,
well, it depends on where it originates from.
True. Right? I mean, if it goes by close enough
you-
to Jupiter, it could
well,
come screaming in quick.
If you actually calculate how fast is the sun moving in its orbit around the Milky Way,
Right.
it's not standing still.
No.
It's a large value. So this comet, is coming in with an appreciable amount of that kinetic energy from its host star.
Right.
There's been several studies, I would say many studies done now, papers that are out there in the peer-reviewed journal illustrating where the comet originated from. And it's all from the thin disk of the Milky Way. So it's coming from the plane of our galaxy. That's
Okay.
where we think it originated based on its orbital characteristics.
Oh, neat. I didn't know they'd narrowed it down.
So it's
that
not coming
much.
from out in the halo.
Okay.
It's coming from the thin disk. So you think of the middle part of the Milky Way as like a pizza or a
Right.
pancake. The closest point to that plane, then we call that the thin disk. And then there's a thicker part of it called the thick disk. And they have different properties, different, like average amounts of metal content, kinetic motions are different. So because of that, we can tell where the comet comes from. And most of the studies I've seen say that it comes from the thin disk. In fact, our sun is part of the thin disk population of stars, as well as our solar system and so on.
The thick disk is usually lower in metals, isn't it?
Yes, that's right, because you get further away, there's less metals. All the metals were concentrated, higher, further generation of stars would have processed that material and increased the metallicity. Out in the halo, it's very metal poor, like globular clusters, for example. That stuff would have collapsed down, presumably, early on, never had a chance for all of these metal productions to occur much in that material.
And one last thing on that topic. Remember, to an astronomer, anything heavier than helium is a metal.
is a metal, including oxygen, nitrogen. They're all metals.
They're all metal.
We are simple creatures. We want to keep things very, very simple.
As simple as possible,
so we
but
can
no
understand
simpler,
it
right?
ourselves. That's right. So far, everything that I've seen, all the observations, all of the papers that have been either submitted or have actually been published now, are all consistent with the idea that this is a comet that came from another star system. We don't know which star.
No. And
Because
there's
it
no
could
way
have
to know.
it could have been in orbit around the Milky Way for a billion
Billions
years
years.
for all we know.
Yeah.
And if you don't get near a source of energy like a star, a comet will not evaporate. It won't lose its material.
Right.
So it could have left some other star system and really didn't fly by near another star, like light years away from another star was the closest it ever got. And this is the first time it's actually getting close to a star where it can sublimate its material and evaporate its material off its surface.
And it won't be here for real long.
No, and exposing all of the fresh, maybe even primordial material from which it originally formed from and whatever star system it originated. So that's an exciting thing.
Absolutely. I
And
mean,
we-
this is great stuff.
And we know it hasn't passed by a lot of stars because you just evaporate all that material away. So
Right.
chances are, right, that this, if it encountered other stars, it wasn't many. In fact, you can almost argue maybe this is the first one or the second
its
one at
host
the
star.
most. Yeah. So that's pretty interesting when you think about that. But it gives us a real inside sampling of what material was like from other star systems
Absolutely. And
without
it's
going
great.
there and making
Without
the actual
going there.
direct observation. This is a free space probe from another star.
Yeah.
We don't have to go there because it came,
came here.
And that's the kind of the cool thing about all of that.
Absolutely. All right.
Now, if you want to learn a lot about STEM fields, about science, about chemistry, which we talked a lot about today, of course, involving comets, or about, astronomy in general and our solar system, all of this stuff. Astronomy is cool because people say, what do you study in astronomy? Everything, right? You study what? You study physics, clearly. You need to know mathematics, but you need to know geology if you want to study the mineral composition of different bodies and so on. You need to know chemistry if you want to study how those minerals interact, how stuff form, the atmosphere of planets, the atmosphere of stars, all of that involves chemistry. It's just almost every science. And hopefully one day, biology will become extremely important. And
Keep
it
our
is
fingers
today.
crossed.
And it is today because there are institutes out there who are, one of the sole purpose is to try to understand what creatures, what life would be like elsewhere.
Right.
Do they have to be like us in terms of the basic building blocks, or can life form from other things, not just being carbon-based with water and all this kind of stuff? And that is biology in a
Right.
nutshell.
Absolutely.
And so you need all of the sciences all combined together to make good progress in astronomy and astrophysics. And in fact, if you want to do that, the place to go, of course, is the Institute of Higher Education,
Learning.
like here, the University of North Dakota,
Come join
where
us.
today we have such great weather.
Oh, yeah. It was pretty nice out there today.
You need to make an advertising video today to get people to come here. We have a lot of great professors, a lot of great staff, and a lot of great students, both undergraduate and graduate.
Yep.
So if you want to get involved in some of this learning processes to find out more about what's going out there, this is a great place. And of course, we have courses on campus and also online.
On online.
So if you live in the middle of Timbuktu, as we say, you can, as long as you have internet,
You
and
can
with,
join
and with
us.
Starlink and other systems out there that are available, there's no reason why you can't take online courses and to enhance
And
your experience as a
and
human
before you
being.
get to our quote,
Yes.
we do have a question.
Yes.
And that is, will the Atlas three-eye Atlas, will it leave any substantial rocks or chemicals? And the answer is substantial, no.
No.
But will it leave stuff? That's what it's doing right now. It's
Yes.
outgassing.
It has a tail and a coma, and all that is material that's coming off the comet itself.
Yep.
So it's clearly populating the solar system. The other interesting thing is if it leaves a lot of dust particles, and if the Earth happens to go through that exact spot at some point, then you get a nice meteor shower. So I don't know if the alignment is right. I haven't looked, I haven't heard, but maybe it will generate, a meteor shower for us in the future. Who knows? That's what Comet Halley does.
That's what
And that's what other comets,
Hale-Bopp and quite a few others.
lots of other comets do as well, for a Perseid meteor shower and so on and so forth. So it's kind of cool. Now, our next podcast,
will be
because Robert is not going to any
I'm
more
not
Dragon
going any
Cons
more
this
Dragon
year.
Cons or anything else.
So, barring some other unfortunate thing, he should be here next week.
Right?
So we will have a pod. I don't know the technical background, which is why I don't do it on my own. I rely on Robert. Someday I'll have to learn everything so I can
So
step
he can
in and
do
do
it.
both roles when he's not here, or because he can do it without me. I just can't do it without him. You see how that works?
Yeah.
So our next podcast then would be on September the 16th.
Yeah.
Now, as Robert mentioned already, we always leave you with a quote. And today's quote is about comets.
Comets. Okay.
Okay.
Kind of guess.
Yeah, it's actually what was written in the Anglo-Saxon Chronicle.
Oh, okay.
And it's related to Comet Halley back in 1066 and one of the approach to the Earth. And you know what was going on back in 1066? Do you remember back that far, Robert? Or did your father tell you what was going on back in 1066?
Oh, I remember it. I remember it like it was yesterday.
So what was going on in England?
That was the Battle of Hastings and the Norman conquest of England.
Yes, William the Conqueror. So all of that. And so there was a Comet Halley appeared in the sky as an omen. That's what they took it as.
Right.
And
Or they claimed after the fact that they did.
yeah, of course. And it's always the winner that writes the history, right?
Right.
So this is a quote that's actually taken from the Anglo-Saxon Chronicle, and it's by Matthew Parker, who was an Archbishop of Canterbury. And so his is known as the Winchester or Parker Chronicle, but
Okay.
it's basically from the Anglo-Saxon Chronicle at that time. So that, looking at almost 1,000 years ago. So here's the quote, or the excerpt, if you like, from the document. 1066. At that time, throughout all England, a portent such as men had never seen before was seen in the heavens. Some declared that the star was a comet, which some call the long-haired stars, because that refers to the tail, obviously.
Tail,
let's see.
right.
It first appeared on the eve of the festival of Latania Mayard, that is, on the 24th of April, and shone every night for a week.
Nice.
I think, if I'm not mistaken, that's one of our earliest recorded records of the observation of Comet Halley or Halley, however you want to pronounce it.
Yeah.
So it's very cool in that sense.
Absolutely.
Yeah.
One of our first recorded.
Yeah,
Yeah.
exactly right. So if you like this podcast, please don't forget to give us a thumbs up, smash that like button. Subscribe if you haven't subscribed. Tune in next week when we'll do this all again and more exciting news, and you never know what happens. That's the beauty of this podcast.
Absolutely.
Because
we're going to talk about it.
yeah, we're going to rely on what's actually being talked about out there in the next week or so, and hopefully it's something really cool, because that's really gets us excited. So please subscribe if you haven't subscribed, as I mentioned already, and if you like this podcast, tune in next week and the week after and the week after that, and don't forget to watch all the other ones we've done in the past.
Absolutely.
Although it's old news, there's a lot of funny jokes in there.
Well,
At least we think they are, right?
We think they're funny.
Anyways,
we think
thanks.
we're a riot.
Thanks for watching. We'll see you next time.
Y'all have a great day.